Respected sir, my name is Lohit. I am explaining about application programming interface in reviews. Our main aim is unlocking the power of reusable software components. Definition of software reuse. Using existing software components or modules in new application. Types of software reuse. Code reuse. Reusing specific sections of code or programming logic from existing software in new projects. This can include functions, classes, or entire modules. Component reuse. Reusing larger pre-built software components or modules that provide specific functionalities such as user authentication, data processing, or user interfaces. API reuse. Reusing application programming interfaces that allow different software systems to communicate and interact with each other. Benefits of software reuse. Improved productivity. Software uses reduces the need to reinvent the wheel, allowing developers to focus on building new features and functionality, which speeds up development and improves productivity. Consistency and reliability. Reused components or code have typically been tested and debugged, resulting in more reliable and consistent software. This reduces the chances of introducing new bugs. Cost effectiveness. Reusing existing software assets can significantly lower development costs by reducing the time and effort required to create new software from scratch. Faster time to market. By leveraging reusable components and code, development cycles can be shortened, enabling faster delivery of software products or updates to the market. Why software reuse is important? First one is time savings. Reusing existing software components allows developers to avoid starting from scratch, saving valuable time and accelerating project completion. Resource efficiency. By reusing code or components, you reduce the need for additional development resources such as manpower, budget, and hardware. Quality assurance. Reused components are often well tested and proven to be reliable, reducing the risk of introducing new bugs or issues into the software. Challenges in software development. Time constraints. Meeting tight project deadlines can be challenging when developing software from the ground up, making it important to leverage reusable components to speed up development. Limited resources. Scarce resources, including a shortage of skilled developers, budget constraints, and hardware limitations, can hinder the progress of software development projects. Maintaining quality. Ensuring consistent, high quality code across projects can be difficult, especially when dealing with diverse development teams or using different technologies. Software reuse helps maintain quality by reusing well-tested components. Definition of an API. An API is a set of rules, protocols, and tools that enable different software applications or systems to communicate with each other. It defines the methods and data formats that applications can use to request and exchange information, allowing them to work together seamlessly. Importance of software reuse. Faster development. Software reuse, such as using existing APIs, accelerates development by providing pre-built functionality. Instead of building features from scratch, developers can integrate application programming interfaces to achieve desired functionality quickly. Reducing errors. Reusing well-tested APIs reduces the chances of introducing errors or bugs into your software. Since APIs have often undergone extensive testing and validation, they contribute to a more reliable and stable system. Increased efficiency. By leveraging APIs, developers can focus on building unique and specific parts of their applications rather than reinventing common functionalities. This efficiency leads to more productive development process and quicker time to market for software products. Next, look at an analogous example, a menu at a restaurant. Think of an application programming interface like a menu at a restaurant. The menu provides a list of dishes you can order, along with descriptions of each dish. You, the customer, cannot go into the kitchen and cook the meal yourself. Instead, you place an order with the waiter, and the kitchen prepares the meal and serves it to you. In this analogy, the menu is the application programming interface. It will provide a list of options you can order. The order is the request you make to the kitchen. The next one is the kitchen then prepares the dish and serves it back to you. Next one is role of APIs in software development. APIs plays a crucial role in software development. First one is interconnections. APIs enable different software components or systems to interact and share data or functionality. They act as bridges that allow application to work together, fostering integration and interportability. Next one is abstraction. APIs abstract the underlying complexity of systems, making it easier for developers to work with them. APIs abstract the underlying complexity of systems, shielding developers from the intricate details of how a particular service or functionality is implemented. This simplifies development by providing a clear and standardized information. Reusability. APIs promote code reuse by offering a consistent way to access and use specific functionalities or services. Developers can leverage existing APIs rather than reinventing the wheel, which speeds up development and maintains consistency. Next one is security. APIs can enforce access controls and security policies, ensuring that only authorized user or application can access sensitive data or perform specific actions. This helps protect data and system from unauthorized access and misuse. Next one is scalability. APIs enable systems to scale by seamlessly integrating with external services or components. This allows developers to add new features or extend functionality without having to build everything from scratch, facilitating system growth and expansion. Next slide talks about components of API. Endpoints. Endpoints are specific URLs. The full form of URLs is Uniform Resource Locators or URIs, Uniform Resource Identifiers, that define the entry points for interact with an API. Each endpoint corresponds to a particular resource or functionality offered by the API. Here is an example link for API. Next one is methods. Get, post, put, delete. HTTP methods or webs determine the type of action to be performed on the resource identified by the endpoint. Common HTTP methods used in APIs. First one is get. That means retrieve data from the server. Post. Create new data on the server. Put. Update existing data on server. Delete. Remove data from the server. These methods define the CRUD. Create, read, update, delete operations that can be performed through the API. Next component is parameters. Parameters are additional pieces of information that can be included in the application programming interface request to customize the behavior of the endpoint. Parameters can be part of the URL, which is a query parameters, or included in the request body. Example, there is a user ID which is question mark is equal to 123. It is a query parameter. Sending a JSON object in the request body to update user information. Response format, JSON, XML. APIs typically respond with data in a specific format, commonly in either JavaScript object notation or extensible markup language. JSON and XML are used to structure and transmit data between the client and the server. JSON is the more prevalent format due to its simplicity, readability, and ease of parsing by modern programming languages. Next one, design principles of reusable APIs. Clear and consistent naming. Use descriptive and intuitive names for endpoints, methods, and parameters. Consistency in naming conventions helps developers easily understand and use the API. Clear and meaningful names reduce the need for extensive documentation. Next one, versioning. Implement versioning to ensure backward compatibility as the API evolves. Version numbers in the URL or as part of the request headers help prevent breaking changes for existing consumers. Next one is document versioning policies and deprecation schedules. Next one is error handling. We have to establish clear and consistent error responses and codes. Provide informating error messages with details on what went wrong and how to correct it. Include error codes, descriptions, and possibly suggested resolutions. Make error responses that is like mission readable. Example using JavaScript object notation. Next one is authentication and security. Implement robust authentication mechanisms to protect API endpoints. Use industry standard authentication protocols like Auth 2.0 or API keys. Enforce proper authorization to control who can access specific resources. Implement security best practices to guard against common vulnerabilities. Example, cross-site scripting, SQL injection. Let us look on another slide how APIs facilitate software reuse. APIs enable software reuse by providing standardized, well-documented interfaces to access external functionalities or services. Reusable APIs act as building blocks for software development, offering the following advantages. First one is modularity. APIs break down complex functionalities into manageable components. Developers can leverage specific API endpoints or methods, reducing the need to build similar functionality from scratch. Next one is code reusability. Developers can reuse API client code to interact with various APIs. This reduces redundant coding efforts and accelerates development. Focusing on core competencies by using application programming interface for non-core functionalities, example payment processing, developers can focus on building unique and value-added features of their applications. Next one is quality assurance. Reusable APIs are typically well-tested and reliable. This leads to higher software quality as developers use badly tested components. Let us take an example in API reuse using a payment processing API in multiple applications. Imagine a scenario where a software company develops multiple applications such as an e-commerce platform, a mobile wallet app, and a subscription management system. Instead of building a payment processing system from scratch for each application, the company integrates a third-party payment processing API like a PayPal or Stripe into all of them. Benefits: efficiency. Avoid reinventing payment processing logic for each app. Consistency. All applications use the same payment system, ensuring a consistent user experience. Security. Leverage the third-party API security features to secure transactions. Any updates or improvements made by the payment API provider automatically benefit all integrated applications. This example illustrates how APIs promote software reuse by allowing multiple applications to share a common specialized component, ultimately saving time, effort, and resources. Challenges in API reuse. Version compatibility. Challenge. Managing different versions of APIs can be complex, especially when you need to make changes or updates without disrupting existing users. Solution: to address this challenge, API developers implement versioning strategies. This involves assigning a version number to each API release, typically included in the API's URL or headers. Developers also provide clear migration paths and documentation for users transitioning to new version. This ensures backward compatibility, allowing existing clients to continue functioning with accommodating updates for new clients. Dependency management challenge: API is often rely on external services, libraries, or components which can introduce compatibility issues if not managed properly. Solution: to manage dependencies effectively, developers use dependency management tools that help track and update external components. Regularly updating dependencies helps ensure that the API remains secure and up to date. Additionally, conducting compatibility testing between the API and its dependencies helps identify and resolve compatibility issues before they impact the system. Next one is security concerns. Challenge: APIs are susceptible to security threats, including unauthorized access, data breaches, and other vulnerabilities. Solution: to address these concerns, it's crucial to implement strong security measures in API development. These measures may include using secure communication protocols like HTTPS, employing robust authentication mechanisms such as API keys or auth for access control, and conducting regular security audits to identify and remediate potential vulnerabilities. By doing so, you can safeguard your API and the data it handles from security risks, which we reuse from different APIs. Next one is best practices in software reuse by using different APIs. Automated testing. First, you have to understand what is automated testing. Automated testing is a software testing technique in which predefined test cases and scripts are executed automatically, typically using specialized testing tools or scripts without manual intervention. It involves running a set of pre-written test cases against the software or application being tested to check its functionality, performance, and reliability. Strategy: implementing automated testing for your API, covering various scenarios and edge cases. Benefits: automated testing ensures consistent, reliable functionality by systematically running tests against the API. It helps catch issues early in the development process, reducing the likelihood of bugs and improving the overall quality of the API. Security measures, that is auth and tokenization. Strategy: implement auth for user authentication and tokenization for secure data transmission. Benefits: auth provides robust user authentication, allowing users to securely access API resources with their credentials. It also provides mechanisms for access control and permission management. Tokenization involves replacing sensitive data with tokens during transmission, enhancing security. This means that even if intercepted, the data remains protected as the tokens have no direct correlation with the original service information. Combining auth and tokenization helps ensure the security of user authentication and data transfer in your API, safeguarding both user privacy and sensitive data. Next one, last slide is summary and conclusion. APIs enable efficient software reuse by providing standardized interfaces. Reusing APIs accelerates development, maintains consistency, and improves quality. Harness the power of APIs to save time, resources, and enhance project outcomes. Start exploring API reuse today to unlock its benefits in your software projects and use different software reuse techniques with different application programming interfaces. Thank you.